Everything that begins, ends. The stars, the galaxies, you. And whether it likes it or not, the universe itself. It had a beginning, 14 billion years ago, which means that somewhere, far down the line, it has an ending too. The strange part is that physicists still can't agree on what that ending looks like. It might freeze, it might tear itself apart, it might collapse into a single point of fire, or it might end in an instant, with no warning at all, and you would never even know it was coming. These are every way the universe could end, and brand new data, gathered in just the last couple of years, has quietly rewritten which one we may actually be heading toward. To understand how the universe dies, you first have to understand the war that's deciding its fate. On one side, gravity, patiently pulling everything together. On the other, a mysterious force called dark energy, pushing everything apart, and, right now, winning. Dark energy makes up around 68% of the entire universe. It's the reason space isn't just expanding, but expanding faster and faster every second. And here's the part that matters. We do not actually know what dark energy is, or whether it stays the same forever. That single unknown, whether dark energy holds steady, grows stronger, or fades away, decides everything. It decides whether the universe ends in ice, in a tear, or in fire. So let's take each possibility in turn, starting with the cold one. For decades, this was the ending almost every physicist expected. It's called the Big Freeze, the heat death of the universe. If dark energy keeps doing exactly what it's doing now, pushing space apart forever, then the universe simply keeps expanding, colder, emptier, for eternity. Here's how it plays out. First, the galaxies drift so far apart that from any one of them, the rest of the universe vanishes over the horizon, and the night sky goes completely black. Then, the stars begin to die. The gas needed to build new ones runs out, and one by one, the lights go out, until the very last star flickers and fades, somewhere around 100 trillion years from now. After that comes the long dark. The only things left are stellar corpses, white dwarfs, neutron stars, black holes, drifting through an ever-emptying void. But something stranger is already eating away at them. The matter itself may be rotting. Protons, the particles buried inside every atom of everything solid, might not be perfectly stable. Over spans of time beyond all comprehension, they could slow, lie decay, dissolving dead stars and frozen planets alike into a thin, cold haze of radiation. Brick by cosmic brick, the universe quietly takes itself apart, and even what's left doesn't last. Black holes slowly bleed their mass away as a faint glow called Hawking radiation, until, after spans of time so vast, the numbers stop meaning anything. Even the largest black holes evaporate into nothing. What's left is the most desolate thing imaginable. A cold, dark, near-empty universe, creeping toward absolute zero. Every particle impossibly far from every other, and nothing, no light, no heat, no event of any kind, ever happening again. Not because the universe was destroyed, but because it simply ran down, like a clock that will never be wound again. It isn't a bang, it isn't a crunch, it's an eternity of nothing. And for a long time, we thought this was almost certainly our fate, until very recently. But what if dark energy doesn't stay constant? What if it gets stronger? That's where the big rip comes in, and it is far more violent. In this scenario, dark energy grows more powerful over time, and the expansion of the universe doesn't just continue, it accelerates out of control. At first, nothing seems wrong, but then the expansion becomes so aggressive that it begins prying apart things gravity used to hold together. First, the great clusters of galaxies are torn loose from one another. Then individual galaxies are ripped apart, their stars scattered into the widening dark. In the final months, our own solar system would be pulled to pieces, the planets torn away from the sun. In the last minutes, the Earth itself would burst outward as the expansion overwhelmed the forces holding it together. And in the final fraction of a second, the big rip reaches the smallest scale of all. Atoms themselves are pulled apart, molecules shredded, until the very fabric of matter is stretched into nothing, and space expands so violently that nothing can exist anywhere, ever again. Everything, everywhere, ending at once. The big freeze ends the universe with a whisper. The big rip ends it with a scream, a runaway tear that destroys not just the stars and galaxies, but the ground beneath you, and the atoms you're made of. Now flip the whole thing on its head. What if dark energy doesn't get stronger? What if it gets weaker? This is the big crunch. The expansion grinding to a halt, reversing and collapsing back in on itself. For a long time, this was considered unlikely, but here's where that brand new data comes in, and it genuinely changes the story. Recent results from a project called decay, the Dark Energy Spectroscopic Instrument, which built the largest three-dimensional map of the universe ever made, hint at something nobody expected. Dark energy may not be constant after all. It may be weakening over time. And if it is, then the force pushing the universe apart could one day lose to gravity. The expansion would slow, then stop, and then reverse. Galaxies that spent billions of years flying apart would come racing back together. The universe would shrink and heat up and compress. Everything that ever existed funneling back toward a single blazing point, a reverse Big Bang. In the final moments, the night sky would no longer be dark. It would catch fire, as every galaxy in existence was crushed together into a rising wall of light hotter than the heart of any star, until space and time themselves were squeezed back out of existence. One physicist working with this new data even put a number on it, a universe with a total lifespan of around 33 billion years, which would mean we are roughly halfway through. The universe would swell to its largest size about 11 billion years from now, and then begin the long fall back break inward. Now, this is still tentative. The data has to hold up, and other scientists are racing to confirm it or kill it. But for the first time in decades, the Big Crunch is no longer a fringe idea. It is back on the table. The universe may not freeze quietly in the dark after all. It may end in fire. And if the universe really can collapse back into a single point, a strange question follows you out of that idea. Isn't that exactly how it began? 14 billion years ago, everything we know erupted out of a single infinitely dense point, the Big Bang. So what if the Big Crunch isn't an ending at all? What if it's a reset? This is the Big Bounce. The idea that when the universe collapses to a point, it doesn't simply stop, it rebounds, exploding outward again in a brand new Big Bang, giving birth to a brand new universe. And if that can happen once, it can happen again and again. A universe that expands, collapses, and is reborn over and over in a cycle that may have no true beginning and no true end, which leads to a genuinely unsettling thought. Our universe, the stars, the galaxies, all of it, might not be the first. There may have been countless universes before ours, each one rising from the ashes of the last, each new Big Bang scrubbing away every trace of what came before. We could be living inside a single breath of something that has been inhaling and exhaling for all eternity. We have no way yet to see past our own Big Bang. But if the Big Bounce is real, then the end of our universe is just the beginning of the next one. Every ending so far takes billions of years. This last one could begin tonight. It's called vacuum decay, and it's the one physicists find genuinely disturbing. Here's the idea. Empty space might not be as empty or as stable as it looks. The universe may be sitting in what's called a false vacuum, a state that feels perfectly stable, but isn't truly the lowest, most settled state it could be in. Picture a ball resting in a small dip near the top of a hill. It looks like it's at rest, but give it the faintest push, and it could roll down into a far deeper valley below. And this isn't only a thought experiment. When physicists measured the mass of the Higgs boson, the particle tied to this very field, the number landed in an eerie place, right on the knife's edge between a universe that's stable and one that isn't. Our best measurements still can't rule out that we are living in exactly that fragile in-between state, quietly waiting, maybe for billions of years, maybe not for a single push. If that ever happens, anywhere in the universe, a tiny bubble of true vacuum would appear. And inside that bubble, the laws of physics would be different. The fundamental forces would change. Atoms, as we know them, could not even exist. And that bubble would expand outward in every direction at the speed of light, swallowing everything it touches. Stars, planets, whole galaxies, rewriting reality itself as it spreads. Here's the part that should make your skin crawl. Because it travels at the speed of light, you would never see it coming. No warning, no flash, no sound. One instant you would exist, and the next, you simply wouldn't. Erased, along with everything around you, by a wall of new physics you never even glimpsed. And it could begin anywhere, in a distant galaxy, in the empty space in this very room. It might already have started, billions of light years away, racing toward us right now. Of all the ways the universe could end, this is the only one that could happen before you finish watching this video. So which one is it? For most of modern history, we were fairly confident. A slow, cold freeze, trillions of years away, settled, almost boring. But the universe just changed its mind. New data has thrown the fiery Big Crunch back into the running. The Big Rip still looms if dark energy strengthens. The Big Bounce hides behind every possible collapse. And vacuum decay could rewrite all of it in an instant, tonight, with no warning at all. And here's the truly humbling part. Every single one of these endings depends on understanding dark energy, the thing that makes up most of the universe, and that we still barely understand at all. We are trying to predict the death of everything, while we're still working out what most of everything even is. The universe will end. That part is certain. We just don't get to know how. Not yet. If the universe collapsing into a single point breaks your brain, wait until you see what the very last moment of the universe actually looks like, counted down, second by second, all the way to the end. That video's on screen now. Subscribe, and we'll keep staring into the things we were never meant to understand.